Good afternoon, dear colleagues. The topic of my report is the estimation of residual fatigue life of polymer composites after a preliminary low-velocity impact. The research was carried out in the Center of Experimental Mechanics of Perm National Polytechnic University. The slide shows the outline of the report, which includes 1. Motivation and aim. 2. Testing and diagnostic equipment. 3. Test procedure. 4. Results and discussion. For laminated composite materials, one of the most dangerous types of load is a shocked impact in transverse direction relative to the layouts of composite. Such impacts lead to appearance of delamination in the structure of the material, which in turn is reflected in a decrease in the resource of structure made of composite materials. Shock impacts are especially dangerous, after which it is impossible to assess the damage by visual inspection of the construction or samples. In such cases, it is necessary to carry out a complex of studies with the joint use of non-destructive flow detection methods. Therefore, they describe the processes of damage accumulation and destruction of composites, as well as for the design and operation of composite products. Experimental data are required on the change of strength and deformation characteristics under various loading parameters, including under cyclic and low speed impacts. Low velocity. Based on this, the aim of the study is formulated like development of scientific and methodical foundations of experimental research and obtaining new data of the mechanical behavior of carbon fiber reinforcement polymer composite materials under complex low velocity shock impacts and cycling loads. Equipment of the Center of Experimental Mechanics was used in the work. The slide shows a photo of a drop weight testing system, system for cycling fatigue testing, and a system for static tension tests. Also in the work used diagnostic system for recording acoustic emission signals and infrared recording system for temperature fields. Of the study was a CFRP specimen with a concentrator of an operational nature. The study was carried out with a preliminary shocked impact by a fallen weight according of the 3-point bending and subjected cycling stretching. In accordance with the developed technique, the value of the strength limit of carbon fiber under study was determined from quasi-static tensile test. The nominal fatigue life Nmax is obtained from test with the parameters of the maximum stress in the cycle sigma max 0.75 sigma b, the asymmetry coefficient R 0.1 and the frequency 20 Hz. During the cycling test, the frequency and amplitude of the loading were selected in such a way that the heating of the sample did not exceed 20 degrees Celsius relative to the temperature of the beginning of the test. From experiments of impact bending, the potential energy Emax was determined, at which the samples were destroyed. Further tests for preliminary impact according to the 3-point bending were carried out in the range from 0.3 to 0.9 of the destruction energy E. Single blows were made across the entire width of the samples. Impact. A visual inspection of the samples was carried out. Microstructural studies and analysis of fracture patterns of prototypes under complex shock impacts and cycling loads were performed using a stereo microscope. When impacts with energies 0.33, cracks formed from contact with strike near the surface of which the impact was struck. While on the front and back sides of the samples, cracks, dents, chips and other types of damage that can be detected by visual inspection wasn't observed. Impact with energies in the range from 0.5 to 0.66 led to appearance of cracks near the back in relation to the impact side, with an increase in the impact energy. Defects were formed in the form of delamination. Subsequently, the fall of the load with the intensity in the range from 0.75 to 0.9 contributed to mixed types of damage in the form of delamination and cracks in the transverse direction with local destruction of fibers. Upon visual inspection, cracks with residual diffraction were observed on the front and back sides of the samples. The photo of fractures of specimen tested for fracture and three-point bending by impact with the falling weight E1 show multiple fiber breaks and delamination in the longitudinal direction. In relation of the orientation of the reinforcement levels. As a result, experimental dependencies of the influence of a different intensity of impact bending on residual fatigue life of carbon fiber specimen were obtained. Analysis of the diagram of the change in the residual fatigue life made it possible to reveal the presence of a shock sensitivity threshold. Impact loads with energies exceed the threshold value lead to a significant decrease in fatigue life by more than 10% of the nominal value of number of cycles, maximum number of cycles, for the studied carbon fiber composites. In the case of fatigue failure without pre-remodeling impact, the carbon fiber reinforced plastic specimen laminated through the entire working area. Broken threads and multiplied delamination are visible on the fractures. Similar fracture patterns was observed for fatigue after impact with an intensity ranging from 0.33 to 0.66. Impacts with energies ranging from 0.75 to 0.90 contributed for a mixed type of fatigue failure. The photo of the destroyed samples shows the zones of fiber rupture with longitudinal cracks. This type of fracture is similar to interlayered shear. The complex use of methods of infrared thermography and acoustic emission was applied. The combined use these methods allows obtaining additional experimental data characterizing the mechanical behavior of composite during cycling test. The appearance and development of defective structure. In order To access the intensity of processes of accumulation of damage, the dependencies of the change in the maximum temperature on the time on cyclic loads are considered. The delta T value was determined as differences between the current value of the maximum sample temperature during cycling loading and the initial one. By summing acoustic emission signals, the values of cumulative energy were obtained, reflecting the degree of accumulation of defects in the material under the action of the load during the entire test. The obtained experimental data are presented in the form of dependencies of the change in the relative value of the maximum temperature, delta T, of the sample on the duration of the cycling stretching. Analysis of that data obtained allows us to conclude that the curve describing the change in the value of maximum temperature is monotonic until the appearance of oxidated heating. At impacts with energies in the range from 0.33 to 0.66, the processes of fatigue damage accumulation occurred in the several stage, which was confirmed by a qualitative agreement of these results. Preliminary shock with energies in the range from 0.75 to 0.90 lead to significant heating at the stage of the first cycles. A localized increase in the temperature was observed in the impact zone. A complex experimental study of the effects of preliminary impacts of various intensities on the fatigue life of structural carbon fiber composites was carried out using the test and diagnostic systems for recording acoustic emission signals and temperature fields. The thresholds of the shock sensitivity of the studied carbon fiber reinforced plastics was detected. The fracture patterns of specimen after impacts and subsequent cycling loads are analyzed. A relationship is shows between structural damage resulting from pre-impact and mechanical behavior under cycling loading. Analysis of the data of changes in the temperature and energy parameters of the acoustic emission signals of the samples obtained in the course of the study made it possible to reveal the differences in the nature of the processes of accumulation of fatigue damage depending on the energy of the impact effects and equitative level.